Okay, let's see what happens here again. So this is equal to the sum from 1 to infinity of, let's say, un, and we have to look at un plus 1 over un, its absolute value. That's the absolute of minus 1 power n plus 1 x power n plus 1 for root 2 plus n times root 1 plus n over minus 1 power n xn. That's equal to the square root of 1 plus n over 2 plus n times xn times minus 1 power n. So that will equal root 1 n plus 1 over n plus 2 times the absolute of x power n. Sorry, not x power n. That's my mistake I just spotted. X power n plus 1 over x power n is just xn. Okay. Now, let's see. I'll change this into root 1 plus 1 over n over 1 plus 2 over n times the absolute of x. And if I take the limit now, as n goes to infinity, this will go to 1 over, oh, no, sorry, we'll just go to absolute of x. And we need, if we wanted to converge, the absolute of x to be 1, so then that means x has to be between minus 1 and 1. What about the case when x is 1 and when x is minus 1? So let's look at the case when x is 1. So that's the sum from 1 to infinity, minus 1 power n over root 1 plus n. That's equal to sum from 2 to infinity, minus 1 power n plus 1 over root n. That's equal to minus 1 minus the sum, sorry, that I should have said there. Oh yeah, no, that's right. 2 to infinity, and now it'll be 1 to infinity minus 1 power n over root n. You just think the first term when n is 1 will be minus 1, and minus 1 will cancel the minus 1. When n is, so that's gone. When n is 2, then this will be positive over root 2, but then multiply by the minus, so it'll be a negative over root 2, which is what the first one is here. Yep. Now, this will be between if I force all of these to be negative. Actually, let me make that even clearer. Minus 1 minus the sum from 1 to infinity, 1 over n power a half. I'll just call this s, just so I don't have to write it again. S. Then minus 1 plus the sum from 1 over infinity 1 over n power a half. Yeah, so the p-series test would imply that both diverge because the p is less than or equal to 1. So that would force the s to diverge. So it looks like in the case when x is 1, diverges. Now, does the logic hold true when x is minus 1? I think the only difference when x is minus 1, we'd get a minus 1 power n here. So the logic would actually hold true. Again, when the case x equals minus 1, s would be equal to the sum. I don't think I have to write it all out. I'll just actually put it in red here. Case x equals minus 1. The only difference is that would be having a minus 1 power n. So that means there's no negative on the top, but it'll still diverge. Yeah. Case x equals minus 1 will also diverge for the same reason. So in total, the answer is converges for x between minus 1 and 1, but not equal to minus 1 or 1, it looks like.